So we're given that W is a function. W, the increasing function W, models the amount of solid waste stored at the landfill, so that at time t equals 0, the landfill contains 1,400 tons of solid waste, and we're given the differential equation right here. And we're asked to find the, use the tangent line to the graph of W at 0 to approximate. Okay, so you can see the question. First I have to find the slope. And the slope at t equals 0 is W prime at 0. And so that's equal to 1 over 25 multiplied by W at 0, and W at 0 is 1,400, minus the 300, and that's 1,100 divided by 25, and that's 44. Okay, so that's the slope. So let's remember what we've got here, the slope here at 44. And then we need a point, and so let's just say this is y as a function of x, and so it's easier for me to see it that way. So y equals the slope, which is 44, times x plus b, and we are given that when at time 0, so we need the point, at time t equals 0, the w is 1,400, and so we just plug in y minus y1 equals slope, which is 44, times x minus x1, which is that. And then if we want to know the slope at x equals, let's see, time t equals 1/4, so we have y equals 1,400 plus 44 times that t equals 1/4. So I basically replaced x or t with x, and we get 1,411. Okay, now it's easier to see for me, a picture of all that, but anyway, I encourage you to draw a picture if you need to do that. And 1,400 what? 1,411 what? That would be tons. Okay, so that's part A. And then part B, find the second derivative. Okay, so the second derivative of W with respect to t is equal to, let's see, 1/25th, so the derivative of the right side is 1/25th times dw dt, okay, and the dw dt is the, well, it's already given, so 1/25th times, this is dw dt, w minus 300, okay, so we get 1 over 625 times w minus 300. Okay. Alright, and what does it want us to do? Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate at t equals 1/4. And so W being greater than 1,400, because it says W is increasing, so we say since W is greater than or equal to 1,400, then the second derivative of W is going to be greater than or equal to 1 over 625 times 1,400 minus 300 would be 1,100, which is positive. So since the second derivative is positive, that means that the function W is concave up, and if we use a line to approximate the value of the function at a certain place, that would be an underestimate. Underestimate. Okay, I got it. Underestimate. Because second derivative is positive, which makes it concave up. Okay. Alright. So then part C. What else do we have here? So part C. What is it asking us? Okay, so find the particular solution. This is the good stuff, okay? So let's be really careful here. So we're given that dw dt is equal to 1 over 25 multiplied by w minus 300. And we're trying to find the particular solution, and so we need to make sure we separate the variables because it's a separable differential equation. So we get 1. So we're going to divide both sides by W minus 300. Okay, and W minus 300 there. And at the same time, we're going to multiply both sides by your dt. Okay, so on the right side, these guys cancel. Okay, and on the left side, the dt's cancel. So what we're left with is W minus 300 dW, 1 over that, dW equals 1 over 25 dt. Okay, well, then we have to integrate both sides, just like we did in class on Monday. And when we integrate the left side, we get the ln. Okay, so we get the ln of W minus 300 equals 1 over 25t, and then don't forget to add the plus c right now. Okay, here we have a logarithmic equation. We convert this to exponential. Okay, I'm going to put the t over 25 right there, so I don't have to write 1 over 25 times t plus c is equal to W minus 300. And remember, W is in our problem at least 1400, so we can drop those absolute value bars. Okay, so W is at least that. Make sure we remember that. And then that same process, okay, that same process we keep going over and over. We have e to the t over 25 times e to the c equals W minus 300. Okay, well, the e to the c is just a constant. Let's just call it a. And so we can write this equation in terms of a, or some constant, multiplied by e to the t over 25. And let's do this. Let's add the 300 to both sides is equal to w. Okay, well, this is where the initial condition steps in. Remember, w at 0 is, let's do that over here. So w at 0 is equal to 1400. Okay, well, when we let t equal 0, this e to the 0 right here becomes 1. Okay, so we get a plus 300. Then, when we use our initial condition, we're able to solve for the constant. A plus 300 is equal to 1400. And therefore, a must be equal to 1100. So we have, then we put this back in, put the 1100 back in for a, and we have our equation. We have, let's make it really official. W at t is equal to 1100 e to the t over 25 plus 300. Now, I don't know what we're going to have to do with that, but for right now, that's our equation for w. Let's see. Find the particular solution with initial condition. Yeah, that's it. Okay. And so there you go. All right, and so that's it. A, B, and C.